started. So actually, last lecture, before we start this lecture, and like the way I was doing it last year, maybe it makes sense. If you think it doesn't, we can discuss it. But we left with some, like with the practical part of the lecture, and we did not correct it at the end of last time. So I would like to start today correcting the practicals that we left last time. So we were looking at types, if you remember. If you weren't, I hope that you can catch up quickly that part, because hopefully it wasn't too difficult. We were looking at the end of the lecture at strings. So at this type of variable that we can use to store either a single character or full strings of like sequences of characters, so text. So yeah, we had some exercises at the beginning. Here I just wanted to remember what we said about using operators on strings. So those operators like multiplication, sign, and addition that in Python can also be applied to string variables, not only to integer variables. So in this case, the exercise was just asking to repeat many times a word and to use those operators. So we have a variable that is storing the sequence of letters that we want to repeat, and can actually just use the multiplication side for creating a sequence of repetitions of these specific words. And then I wanted to also have you using the plus operator, plus remembering, like, consider how to use brackets to keep the sequence of operations intact. So I wanted to you to add the space in between those words, but I want you to do it using math strings, so operators on strings. So the idea here would be to first add the space, and to add the space, we can do something like this. And this, you don't see it. Well, you actually do see it. Oh, and please tell me if this is small, because probably for the people who are in the back, it is small. So stop me when I start talking and you're not seeing, and like just scream. Is this better? Everyone sees me? The old people? Let's say a bit more. Okay. So the idea is we can, like, yeah, we are just printing this variable, and remember what we said about the fact that in a notebook, if we just leave a variable, in this case is actually the variable that is coming out of the combination of the quantities, everything that we leave at the end of the cell will be printed. So if at the end of the code cell I just write this will be printed as in the printing part of the cell. So using this plus sign, we are actually adding this empty space over here. So if now we put all of this in brackets and we multiply by 40, this gives us the word with the spacing. And I mean, we have not discussed sequence of operations, but like is what you would expect from like your math background. So like nothing weird about it. Remember to add the brackets if you need the brackets. Okay, so then we wanted to use the, here I wanted you to use the format method, and you remember that we use this word methods to talk about like functions that could be directly called from the variable name. We will be seeing, we'll be talking more about this today, so don't worry, like this concept will come back again and again. So we want to add some new string instead of those brackets over here. And in Python with strings, we can put new text or also format numbers into text using this format method. And this format method is actually called from the variable. So we can say dot format. And actually we can assign, let's say, we can assign the result of this operation to a variable, which I called repeated word. So if we print repeated word, it actually has the content that we were just seeing. And now I can put this word here, passing it to the format method, and this will format this variable, which is this part of the string, inside the rest of the string that happens to be here and here. Okay. Okay, and then last I wanted you to use the this so-called split method, which is a method that separates text based, let's say, in the, if we do not pass any argument, it actually split it using, like, every time there is a space. And if we use the split method, we can actually say that this list is separated, like this text is separated in like something, which I haven't told you what this is yet. Maybe I mentioned during the lecture, but we have not seen what this is. And you actually had to figure out what this was, like the type, what was the type of this operation. So this was just a refresher of the like type function that we can use to check out the type of a variable. And if we ask what is the type of the output of this split, we can see that this is a list. And list is something that we have not been seeing during the last lecture, but this is something that we will start looking right now for this lecture. For, I don't know if like people who actually try to went through these practicals, if you have any questions or like alternative solutions, stuff that were not clear for what we just did. If you don't want to ask now, you can also just feel free to ask when we will be around for the first practical of today. Okay, so let's go to the content for today. So yes, today we will actually start talking about those probably more interesting kind of variables that we will be using extensively in Python, which are, well, we just introduced lists. We will see what lists are and why they're super useful. But we will also look at like some other things that are very useful and I encourage everyone to use, because many times maybe people just stuck to lists for like no reason, when there are many other options that makes very convenient for very convenient code solutions, which are dictionaries, tuples, and sets. We will talk about all of this. And hopefully, after we went through all of this, we will have all elements to actually start doing something interesting with our code. So not just assigning variables and check out their types, but maybe also start writing first programs. So loops, conditionals, we'll start from there. And we see how it goes. And yeah, again, I felt I was not interrupted enough last time. Please stop me if, like, I'm happy to repeat anything that we go through, and yeah, if it's not clear. So yes, those variable types are what are called data containers, because you can imagine many times you actually do not want to keep single numbers as separate variables, but you can imagine you have many data that I do want to keep all together. I don't know, numbers out of a questionnaires or recordings or whatever. And the most basic way in which we can keep together many numbers are actually lists, and that's where we will start from. A list is, like, definition is an ordered sequence of values of any type. So the important thing is values of any type. We can actually put anything that we want in a list. In a list we can put strings, we can put integers, we can put floats, we can put booleans, we can put other lists, we can put anything that we want in a list. And this is one important part. The other important part is that it is ordered. So there's elements from 0, because we remember, like we saw last time with strings, that Python indexing starts with zeros, and go from 0 to something, and they're ordered. So in this case here, yeah, and in terms of like practically how to define a list, we put all the stuff that, like, this is one way, we will see other ways. But the most basic way is we put all elements that we want to store inside this list in square brackets, okay? So in this case, we are assigning a list with 4 elements. One element is integer 1, second element is bool true, then we have a string, and then we have a float value. This is pretty useless. Most of the times you will put like the same thing in a list, but you have the flexibility to put whatever you want. And so it has some number of elements, and we can quickly check how many elements are in a list using this function that is called len. Okay, so if we write len of a list, this returns 4, which is the number of stuff that is in that list. Remember, you see that this oh, are you all seeing this text? Okay. remember that like you see that this is green. Green means that you do not want to use len as the name of any other variable, okay? Because if you write something like len equal to len of a list, like something like this, you won't be able to use the len function anymore. You will have to like restart your Python kernel. So don't do it. Like always do something like len. Even just this is already fine. Like len underscore, it's enough for Python not to be confused. But don't use len as variable name. Okay, so here we are just checking how long this string is, but there are other things that we can do. For example, the most common operation that we do with lists is the operation that is called indexing. So when we do an indexing operation, we are taking the string variable, we are taking the list variable, and we are extracting one of the values that are stored inside that, that list using an index. Okay, and indexes works in the same way we were seeing them in strings, and it will take some time. You will get more and more confident using those, performing those indexing operations. But remember, when you index, you again use the same square brackets that you were using for defining the list, if that can help remembering about this. Again, careful MATLAB people, because like this is very different from what you do with MATLAB. In Python, square brackets after a variable means that variable is something that I can index, so is a variable that has multiple elements inside. And of all those multiple elements, I'm taking the one with index 2, which is which element in order?
The third.
The third, exactly. So this is the same list that we were defining before, so the third element was the string. And so the outcome of this operation is this value. Okay, so I could potentially assign the outcome of the indexing operation to a new variable name, something like third element equal to, okay, and now the value of third element will be this. Okay, all clear? Makes sense? Good. And one very important thing about lists is that the content of a list, after we assign, like we define the list variable, and afterwards the content of that list can be modified. Okay. So for example, now this is still the same list that we have before. So we can say something like this was that, but we can use the same indexing operation to actually put something new in that element of the list, in that position of the list. Okay, so if I say a list 2 equal to, let's say, new content, we do this operation. After this operation, the variable has been changed to a new sequence, which where now that element in the third position has been replaced. Okay. And yeah, actually, maybe before doing this operation, let's focus a bit on what we are doing here. Do you remember what were we doing when we were using this kind of indexing over strings? Anyone who remember what that syntax over there was for?
You're selecting that specific letter of the string, or the range of.
Yes, exactly. So with the strings, we were selecting a range using the like number, column, number, and the same with the list. So when we like in this case, we are actually getting a pretty stupid range, which is just from 2 to 3. Okay, so just only one element. We could take, I don't know, 0 from 3, which would be all the first 3 elements. Remember that 0 means we start from the first element. Third means that we get everything up to the fourth element excluded. So this is up to the number that we write, excluded that number. And this will be confusing at the beginning. And at the beginning, many times you will write a number and you will realize that probably you like are off by 1, but this will stick at some point. And just as a refresher, but like you will be drilling those in the exercises. So like hopefully indexing operations, as I said, they are to be memorized. Like it's something, there are patterns that you will have to pick up. So hopefully in the exercises, we will be doing those many, many times. But remember that we can omit the first element if we want, and this like just assumes that it's 0. We can omit the last element, and this assumes that we are taking everything up to the very end. Okay, so this operation is basically not doing anything, because this is taking all the content of the list from the beginning to the end. This is taking from everything from the third value to the end, so just those two numbers. This is taking from the second to the third. And now that with this kind of indexing operations, everything that we just said for like indexing operations of only one value holds true. Like this is the same. So if we assign some value range equal to, now this new variable that we are assigning is not a single value anymore, but will be a list, just a restricted list with a subset of the elements. Okay, so this value range will just have like this will be just a list with only two elements. And in the same way, we can actually overwrite the content of this range of the list with some new values. So instead of true and new content, we can say that this will now be, I don't know, 3 and 5. Okay, so we change this content, and now the list is 1, 3, 1, 3, 5, which are the new values that we've put, and 3.14, which was there from the very beginning.
I do have a question.
Sure.
Imagine you have a super huge set, super huge list, and you don't know how many rows or how many elements are actually in the list. But you want to pick up the two from the end, like.
Yes. Oh, yeah. True.
N minus 2.
Yes, actually, very good point. Thanks for raising. Yes, instead of writing numbers counting from the beginning, I don't remember how this is done in MATLAB. So
N minus.
yeah. Okay. So in MATLAB, what you would write like n minus 2, something like that.
I think so.
In Python, just becomes minus 2. Shorter, so better. No, like, not necessarily. But this means take all the elements apart from the last two. This is all elements apart from the last one. Okay, and yeah. Also minor thing, but we'll probably, like, I will mention it now, probably it will be confusing at some point, and probably it will stop being confusing at some other point. Remember that if we do, so for example, this indexing operation, right? Like this is a range from 2 to 3. So basically this is picking up only one element. The thing is, in Python, if we were to do something like this, so we actually get that element, the outcome of this indexing operation is one single, like an actual integer number, which is the integer number that was there. If we use a range, so if we say take the range of the list from 2 to 3, Python consider this as being a range, and so the outcome is still a list, even if it's a list with only one element. So be considerate of that, because if you were to like work with like if you assign something like this and you say indexing outcome equal to, now the type of indexing outcome will not be integer. This will be a list. Like even if it's a one element list, this is still a list. Which can be annoying, because if you try to do like operations on it, let's say you get an error because like there is no meaning in a like power elevation for a list. Okay, because in this case we are not applying the operation to a list to an integer, we are applying the operation to a list. So make always sure that if you're indexing with ranges, you expect ranges. If you're indexing with single numbers, you get out individual elements of the list. Yes? Oh, sorry, it wasn't a question. There is a question?
How to count excluding the last elements, but you can also start counting from the end. Maybe it's worth showing it, like instead of
Yeah, we
No, you did like double dots -2, not -2 double dots.
yeah, sure. So when you like this use of negative numbers that we were using, so we say that something like this takes all elements. Well, let's stop assigning to a variable. This takes all elements apart from the last two, okay? Because we are stopping counting at 2 from the last one. Because we are using the -1 in like after the columns. Anyone who wants to get what we would get out of this operation? Yeah, so with this we will exactly take the like second part of the. So everything from -2 elements from the beginning of the from the end of the list to the end of the list. Sounds good? Reasonable? Okay, but yes, we will be drilling this. Yes, another important aspect of a list is that the length of a list is not fixed. So we assign a list, and let's keep defining this 4-element list. After we define the variable that contains the list values, we can actually extend this list. We can add new elements at the end of it. And we do this with the append method. So remember, a method is a function that we called from the variable. So we have this variable, which is a list, and we say dot append. And methods are similar to functions, so we actually pass stuff to them in square brackets, like they take inputs, and those inputs they get in round brackets. And here we are giving as input the new value that we want to be appended, like that's the appended at the end of the list. So new value. And we can check how does the list look afterwards, and we can see that now it has 5 elements. We can actually check with len. Just as a reminder. Oh, sorry, what happened? Oh yeah, sorry. I was assuming it was a length for list. So yes. One important thing to notice here. So we are using the append method. We are not assigning any, I don't know whether to say this now, or does this look, anyone feels that there's something odd here? Because if there's not, I will actually not confuse your minds. Does it make sense? Okay, so I won't get into what might be odd here, but it will come up.
How do you remove one element?
We'll get there, I think, probably next. No, yes, sorry. Shit.
Now we are confused actually.
Yes, you were saying something.
The length of the list is 5, right? But you have appended something, but you haven't stored the appended thing in a
Exactly. Okay, so this is the confusion. So this operation, probably what you would have expected, or some people might have expected, depending on how you're used to work. Maybe some would have expected something like new longer list equal to this operation. Okay. Now, funny thing, if I do this, and if I look at what's this new variable, it's not printing anything because the content of this variable is actually none. And why this is the case? Because in this case, this append method is actually changing the variable itself. It's not returning as the output a new variable with all the elements of the list plus this new one. This is changing, and the word is called in place. So this operation is actually changing the content of the variable that we defined in the first place. Okay, so after we have called append new value, we won't have anywhere in our memory these elements with this list with only 4 elements. There will only be one list with 5 elements, because we assigned we defined one list with 4 elements. We changed the content of exactly that list so that now it's 5, and the list that was 4 now is 5, and what was 4 is now gone forever. Like it has been changed to 5. We are not creating a new variable of 5 elements. And this is actually very important distinction, which at the beginning will probably be a bit odd.
It
I don't know.
might be confusing when you want to copy lists.
We will get there actually. So, yeah. But yes, this is important to know. So remember that if you actually want to use this append method, you just call it like this, and you don't have to define a new variable with the extended list. If you want to actually keep the original content of the list before it was changed, we will see how we can do it. Okay, so this is what Federico was asking. There is also a way of taking elements out of the list, and this is usually like, maybe you will end up doing it. Like, don't use this function, like this method very often, but there is this pop method, which should be used just because it's called in a very funny way. But so you can pop elements out of the list, and after you, like the pop method will actually, let's clean this. So we have this initial list of 4 values. When I say a list dot pop, so if I can just leave it without any indexing specified, and if I just pop without passing any input, this pops the last element. Okay, so I was putting 4 values. This is pop, like, let's remove this print. This pop method is taking the element 3.14 out of the list. It is actually returning us the element. So in this case, this function is returning a value. So if we assign, I don't know the part, like I hope this makes sense. So if I write something like this variable will actually be the last element of the list. And exactly as calling append change forever the content of our variable, also calling pop changes forever the content of our list variable. So if we look at what is inside the list after we have called the pop method, now the list actually have 1 value less. Okay, it does not have that last value. So this means, like, this is the distinction between like calling the pop method and indexing that value. So we could also just index it, if we really cared about just getting this value without modifying the list, we could have just write something like a list -1. This will take the last element, but will not change the list. This will just get the last element out of the list. Okay. If we actually write .pop returns us the same value that we would be getting with the indexing, but also take it out of the list. So actually that's not like a weird, like not weird, but like that's something that you do in very specific cases. Usually you don't want to change the content of that list. Make sense? I see confused faces.
Can you also pop elements in other?
Oh yes, sure. We can pass numbers inside the pop, and the number is the index of the element that we want to pop. So if we pop like 0, this is actually popping the first value. And
It's like to remove
exactly.
elements from a list.
Exactly. Yeah.
You can't append in the middle of a list instead.
No, you cannot append in the middle. So if you want to put new stuff inside the list, like usually you just change the content of a list. If you want to put up new stuff inside, we will see how to do it. Like you basically have to concatenate the first part, the new thing, and the last part. Yeah, we are actually very, very close to this. Like if we want to concatenate lists, so we have the list that we had before, and we want not only to add 1 element at the end, but we actually, oh, sorry, there is a question? No, yes.
Yeah, I was just wondering what that is used for then in the end, because, I mean, for me, I haven't worked with Python before, and I get all this information. Yeah, you can do lists, you can pop things in out, great, but what do I need it for?
That's what I would say. Like pop is quite uncommon. Like there are some algorithms where it is useful to, I don't know, remember like, because maybe you have to do like to search a tree of elements, and you want to visit locations, and you want to take them out. Like you have a list of locations to visit, and every time you go there, you actually want to remember somehow that you visited that, and so you can just take that location out of the list. There are some algorithms that make sense to where it makes sense to use this.
But what do we use the lists for?
We will get there. Many things.
Element go anywhere or it just vanishes?
It returns as you get that number as a variable that you can assign.
Okay.
If you don't, it's just gone.
Yeah, otherwise okay.
If you don't assign it to a new variable, that value is just gone forever.
Is this the equivalent of the MATLAB cell array, I guess, if you are used to MATLAB?
I don't know shit about MATLAB. Maybe people who has that experience can.
They look like.
Yeah.
They look like.
Okay, I take your word for that because not a knowledgeable
We can say
person.
anything about MATLAB. But
Sorry?
we can say anything about MATLAB.
No, a little bit, but I was not using.
Red card mentioned MATLAB.
Sorry? Exactly. Third time you're out. Okay, so sorry, we were actually here. So we can add new. Actually, we can combine list of stuff. So just imagine that we have this list of 4 elements, and we want to combine it with another list of some not just append one variable, but actually adding many new values at the end of the list. So we can just say something like A, B, C. Yes. So the plus operation on list, just put I think is intuitive. You just concatenate the elements that you're adding.
But with the append, you can only add one.
Exactly. There is actually one. Probably I have it in the next slide. Yeah. There is one thing that you can do is instead of append, you can say extend, and you pass a list of A, B, C. Okay.
So doing this, so extend and doing plus and the list
Yeah.
will do the same thing.
They are doing slightly different things because extend works in place as append. So if you actually extend the list, you are changing the original variable that you were assigning.
Okay.
Okay.
Yes.
So I list.extend ABC, and now I say a list equal to this list. A list will now be this. Okay, so anyone wants to guess? Remember, a list is something that we define some cells up in the notebook. So anyone wants to guess what happens if I run again this cell over here where I am not redefining a list?
Can you repeat the question?
So in this cell, when I'm running this cell, I'm just running this operation and then printing this value. While in the previous examples, we were defining a list, then, for example, appending, and then printing out. Okay. Now I'm missing the line where I'm saying a list equal to 1, 2, A, B, whatever. Okay. Because I already defined it upward. Yeah. So what happens if I now the content is we have 1, 2, 3, 4, 5, 6, 7 elements in this list. What happens if I run again this cell now without redefining the variable? How many elements will we get in the list? Exactly. So we are changing inline. So whatever, it will explode. It actually exploded. Yes. Let's keep it this short, otherwise. Okay. So this is changing the variable in place. Yes.
Is there any specific advantage in using extend instead of plus?
Yeah. So actually, first answer would be no. Just do whatever you want. Just remember that this is doing in place, because the alternative would be let's take what are the full 2 alternatives. One option would be this extend. The other option would be calling something like extended list equal to a list plus this, okay? And now if we actually go and look what is extended list, this is basically the same that we would get after extend. So the difference would be the following. Like if we actually care to keep the original variable, this is what you should be doing. If you actually do not care that much about keeping the list with less elements, there is no point in keeping two different variables in your code. That's that's what I would say. But I mean, it's also a cosmetic thing. Like it won't really matter that much. If you don't remember what extend means and you feel that plus would be like would feel more natural for extending the list, you can just stick to this.
Can I ever write a list with itself? So for
Yes.
example, can I write a list equals to a list plus
Absolutely yes.
Okay.
So very valid point. There is a very minor thing, like people who are new to code can just forget about it. People who are maybe a bit more curious can like keep the brain on. But this thing is doing something slightly weird performance-wise, because in one case you just put somewhere in the computer a variable and you're just updating its content somehow. In this case, you are taking the time to redefining a new variable that has a new name but will be located somewhere else in memory in the computer that just keeps the old value and the new ones. So if those are like 5 numbers, who cares? But if those starts being for whatever reason, like lists of thousands of elements, doing something like this would be way less efficient than just extending. This is those are the kind of considerations that, this is why like all those things there's many alternative syntaxes if you do them on very simple elements, but all those things may come up again if you start caring about performance of your code. But if you don't, like forget about it.
Can I ask another question?
Sure.
Sorry. Always in the logic to have a bigger list than this. It is possible to extend or append or whatever or plus a new list in a specific range of positions.
No, so okay, so this comes to the question that someone was raising about how to add elements in the middle. So to add elements in the middle, actually there is no alternative to just say something like, oh, no, I don't know. Maybe I'm missing. So sometimes it happens that, okay, so I was saying something stupid. Like sometimes with Python, you don't know about something and you guess what the answer could be. Like maybe there is an insert method. There actually is an insert method. I just don't know how to use it. There is a way of getting instructions, which should be like question mark at the beginning. Yeah, so this is actually getting, taking as arguments the index where we want to put the new thing and what we want to put. So we can say something like insert in position 2, the string value inserted. Okay, so we can actually put stuff inside the same variable. Neat. Good. And yeah, just minor thing, exactly as with the strings, where we could do just, plus operations and also multiplications. Also for lists, we can do multiplications. So, well, this got cut, but it's just the same list. Like if we multiply, maybe we can actually look at it like here. So if we multiply times 2, we get a list that is twice as big, that has all the contents repeated twice. And actually now is a good time to stop and go through the first practical exercises where we will be looking at lists. And yeah, we will be going around, so feel free to ask anything. So everyone, in the first problem, we had to use the split method to separate the string based on spaces in a list and assign this list to a variable. So we can say word list equal to a string dot split. So this will split the list and return us the list of separated words, and we assign the outcome of this operation to the variable word list, which is now a nice list of strings of some 20 something elements. Okay, then we were asked to use indexing on this list to take 1 every 2 of the first 10 elements. So this was like just a to refresh, to drill a bit indexing operation. So the full extended version would be doing something like this, for saying from the first element to the 10th element every 2. But you remember, we can potentially also just omit the first number if it's a 0. And so this should be like actually 5 elements, because it's like every 2 of the first 10. So this makes sense. Okay, so now we have this new variable, which is called selected elements, which is just 5 elements long. And the idea will, like here, we want to replace the first element of this list with a new string of whatever choice. So we can say this to index the first, and we assign the new value, and we can check this variable after we have changed the first element. So now we have one first element that has been changed. Okay, then we had to use the append method to introduce a new variable at the end, a new value at the end. New value at the end. And remember that this is changing the variable itself. So we do not have to write something like selected elements equal to selected elements.appends. Because actually, if we do something like this, since this operation append is changing the variable but is returning none, if we do something like this, and someone did, we basically assign the none to this variable, so we overwrite our list value with none, and we have lost that variable forever. So remember that when you use those, again, they're called in-place operations, you do not have to assign the result. I mean, unless it's like something like pop where you actually want to, but for append, you never assign the outcome to a new variable. And so, can someone tell me what happened here?
Run the same cell twice. So
Exactly. So by mistake, I've run the same cell twice, and so actually 2 times this was appended. Okay, but it's fine. Okay. Then here I was asking you to check out what was happening if we were appending, like instead of appending, like in this case we were just appending a string. Let's assume that we define a list. What happens if we append a list? So someone want to say what? Well, whatever. A list is appended inside the list. So this is not extending the list, okay? Because if we count how many elements are here, we just have one element more. But that element is actually a list. So now we have a list, and one of the elements of this list is a list. So remember not to do append and a list if you want to extend. Like sometimes it makes sense to put lists inside lists, but this is not what you want to do if you just want to extend that list. Okay. So yeah, here I was just asking you to.
Wait, sorry. So how do we extend using append? No. How do we extend multiple elements?
So we can use the extend method instead of append.
Oh, right.
That we used, or use the plus, like the 2 options that we saw. So we can say concatenated equal to selected elements plus to concatenate. So this would be it. We are constantly working on the same variable. I'm never redefining it. So we got all the crap that we collected in the previous cells, but now at the end we have 1, 2, 3 new elements that are the 3 elements in the list that we use use in the plus operation. There was another solution, which is we could have also been writing selected elements dot extend to concatenate. Remember that this is now an in-place operation. So again, the outcome of this is none, and this will change the value of selected elements. So now selected elements has been changed as a variable. So this is the difference between using the plus operation and the extend method. Yes?
How can I access to the list that I appended to my original list?
Okay, so now this
Single
is
elements, for example.
this is 1, 2, like 0, 1, 2, 3, 4, 5, 6, 7. So like let's write a new cell. So we can say this. So this is a list. We index this element, and this is a list.
Yeah.
And now we can work with this as if this was a new variable. So if we want to do it in 2 steps, we can write something like this. So now this variable is a list that we can use exactly the same way as previous list. But we can also directly, so which means that potentially just the outcome of this indexing is a list. So just imagine directly applying to the outcome of this indexing operation a new indexing operation, and the way we do it is we can just add another indexing operation like this. Okay, so this will be one indexing operation returns the list, second list operation returns the element from the list inside the list. Okay, good.
Can I ask something?
Sure.
Maybe we will see it later on. But can I like import a list from a file?
Oh, sure. There will be plenty of time to work on like how to get values from files. That's what you do most of the times.
You know, if we accidentally add the elements, you know how you did, you ran the code twice, so it added the things twice. Is there a way to undo that?
No.
You
No,
know,
like
it's
so
from the
yeah.
start.
So and that's actually why generally you write like when you work on file that is like run through multiple steps, like in the notebook. Usually, when you write pieces of code, you always have in the same place the definition of the list and all the append operations that are happening. So if you just rerun the code, like everything runs together. Usually, you do not have, like I would not recommend in general like doing what we are doing now in a script. But you'll see, like actually, when you use those lists, it's not common to do those kind of operations in separate parts. Now we are just keeping the same values as. Okay, so we should probably start on, like, we were doing kind of some minutes break last time. I don't know, we are a bit short today because we spent some time at the beginning with the names. So I don't know if people feel like we should be doing a pause or we can keep going, how fresh our minds. Okay, let's try. Good. So the next data structure that I wanted to introduce is dictionaries. And dictionaries, I've been seeing many people who start coding in Python. List feels like natural to some degree to them, and I don't know, potentially more like MATLAB-ish in concept, and they actually never use dictionaries, which are to me like a very useful variable type that I would highly recommend. So make sure you know what dictionaries are, because in dictionaries we can again put multiple stuff and retrieve this stuff with indexing, so we can keep a bunch of like variables of many types together. But now, instead of having to remember in which position we have put every value, we can actually give every value a name. Okay, so instead of defining a lot of variables, we can basically define one macro variable where we call the locations, like the sub-locations where we keep individual, for example, numbers. This is very useful, for example, if you have metadata of an experiment. You can imagine creating a dictionary of metadata. So you have one single variable that contains everything, And in this variable, instead of remembering that the first position was frequency, the second position was time of the experiment, the third position was name of the subject, whatever, we can name the stuff that is inside the dictionary. So yeah, for like in practice, this means that we can do something like remember before we were saying like square brackets and just everything together to define the list. What we are doing here is we are using curly brackets, and instead of just, we also have to give the names to the elements that you are putting inside. And the syntax is string that stands for the name, or like, well, for now, let's say string that stands for the name, colons, and then and the content that we want to put in that named location, and item B, and then the content that we want to put in that location. And after we have defined a dictionary in this way, we can actually get elements out of that dictionary. Instead of using numbers, we can index using strings. Okay? So what do you expect is the outcome of this indexing operation? 1. Okay, so this makes for much more readable code. Like if I define a list and it has 10 elements and then I do a bunch of stuff and at some point I index third element of the list, if I want to understand what's happening, either the list is, I don't know, a time series where like I don't really care about, like it's just a number, or if I'm getting, like if I want to know what I'm getting, I have to like go all the way back where I was defining the list and figure out what I was putting in the 10th position. Well, if I just read this line of code, I know that I'm retrieving something that I was naming in some certain way. Okay, so this is a very kind of readable way of keeping together multiple values, and I hope that will be easier to appreciate when you actually start working with them. And remember, there are basically 2 ways of defining dictionaries. So one is this syntax with the curly brackets, and then string colons value, string colons value. This is one option. There is another option that is calling the dict function. But yeah, probably actually for now this is more complicated than useful. So let's just forget about this option and let's just stick to the first option for now. Okay. Good. So yes. So I was saying that so basically in a dictionary we are free to choose whatever we want as indexes for those values. We are not just indexing using numbers. In this case, we were like in the previous example, we were indexing using strings. But just remember, like probably 99% of the times you will be writing dictionaries, you will be using strings as the indexes because those are the things that makes the most sense. But this is not necessarily the case, and exactly as for the content, in the content we can put whatever variable type. We can also put whatever variable type as the index of the string. Okay, so in this case I'm defining an index of the dictionary. So in this case I'm defining a dictionary where instead of using strings as they are called the keywords, I'm using integers. So I'm deciding that whatever I will index with integer 10, like when I will be indexing with integer 10, I will get the false value. When I will be indexing with integer 20, I will get the true variable, the true value. So now, even if there's just 2 elements, I can do this indexing operation because this is not, like, since this is a dictionary, this indexing operation is not saying take the 20th element. This is telling take the element whose key is 20, and the element whose key is 20 is true. Okay, but like this is just for you to know. Most of the times you will actually be just writing strings as keys. And if I have not said that explicitly, like in dictionaries we call about keys and values. So keys will be whatever you use for indexing, and values are the stuff that we put inside. Okay, so exactly as for like in lists, we were also modifying the content of the list. We can do the same for dictionaries. So if I define this dictionary, and yeah, let's just keep a consistent syntax. this. So I'm defining this dictionary, and then I am changing the content of item A, which previously was 0. I am now assigning 5. Sorry, this was string. So now I have changed the dictionary variable, and now the first item will be 5. Okay. Okay, we can also add new stuff to dictionaries, actually in a way that is even probably feels even more natural than lists. So let's assume that we have this.
Wait, where did 5 come from? Sorry.
Sorry?
I missed where 5 came from.
Oh, I just assigned 5 to the. So I say something like. So I have this dictionary, okay? I have item A and item B.
Yeah.
And I want item A instead of like at the beginning its value is 0, but I actually want for whatever reason I want to override that value. So I was just writing something like item A equal to 5. Just like could have been whatever. Could have been item A equal to true. Okay. I can also very easily add new elements in a dictionary by using the indexing operation, using strings that has not been defined as keywords already. So if I do something like, if I try to index with new index, so this does not exist. So if I just write something like this, I will get an error. Python is telling me that there is no key named. We probably, I don't know, at some point we will have to do something about reading errors. Probably at the end of the lecture there is something. But yes, this is a key error, which means like I am trying to use a key that does not exist in the dictionary. So obviously like this operation, this indexing operation trying to retrieve the value cannot be done, but it can be used if I'm using this indexing to actually assign a new variable, assign a new value to that keyword. So if I say something like this is actually adding a new index keyword and that has the 5 value. So now the dictionary will have three elements inside. Yes?
Just to be sure, every key refers just to a single value. It can
Yes.
contain
Yes.
okay.
This is actually very important.
Okay.
Yes, there has to be a one-to-one correspondence between keywords and values.
Okay.
Can you also change the name of the key? Or
No, you have to do it you have to do it 2 steps. Like you have to assign a new key that has a content that is the same of the. And then actually popping that element out, because exactly like lists, we can also shorten dictionaries. We can take elements out of dictionaries using the pop method.
Luigi, can dictionaries be like, I don't know how to put it, indexed? You know, maybe.
Are they ordered? Yes, so they are also ordered.
Maybe in the same dictionary there can be like dictionary index 1 that contains the first list of keys.
Yes.
First
So
list of values that correspond to those keys, and dictionary number 2 that corresponds to
So they are ordered, which means that you can iterate as like we will get to there. But if you actually try to index with numeric indexing, you actually will get an error because like there is no key 1 defined.
No, maybe.
No, so.
But never mind. We bypassed it.
Okay.
It's a rather complicated thing.
Okay. And yes, pop works as we were mentioning. Okay. Yeah, this is what I was saying before. Like dictionaries, I strongly encourage people to use dictionaries because they are a very, very sensible type of data. Okay. I wanted to spend some time on this because this is something confusing that can happen that we have to be aware of. So whenever we are writing something like this, and this applies to both lists and dictionaries. If we do something like this, so we define a list that has 2 elements, and then we define another list as being the first list, okay? So now, just imagine we want to change the content of another list. So we say another list, in the first position, we put a new value which is actually a string, okay? So I am changing the content of another list, and as we can expect, another list is actually changed. What do you expect will happen to a list? Sorry? Nothing. Oh my gosh. So nothing. So we can actually check whether this answer is true. And this is actually not correct. We have also changed the content of a list. And this is because lists, like you can imagine a list as being basically a placeholder in the program for like marking a position in the computer memory. Okay, so whenever I assign a list, Python say, okay, computer memory from like in this little corner in the RAM contains the numbers that I'm putting in the list. When I'm doing this operation of another list equal to a list, and like this is different from probably from what happens in other programs, and this happens because Python overall is more transparent regarding to those operations, which can be confusing sometimes. And this is why like I'm putting this out. You will get to see it when the concept start sticking. But when we are doing something like another list equal to a list, we are basically assigning a new variable, which is basically a placeholder for the same location in memory. Okay, so if you look at how much RAM you are using, if a list is actually a gigantic, like 2 gigabytes amount of data, when you're writing another list equal to a list, you are not allocating another 2 gigabytes of memory. You are just pointing to the same place with the same 2 gigabytes. So this is why this is happening, because like this is important if you want to like work efficiently with stuff. You're just writing a new name that is pointing to the same thing. But this means that if you are changing, if you're using one of the 2, so those are basically aliases for the same stuff in memory. They are just 2 different ways in which I'm calling the same thing. So if I change one, I will also change the other. If I do not want this to happen, I have to tell Python explicitly to duplicate the data. And this I do with the copy method. Okay. So if I want to duplicate all the content of a list in another list that I can work with, making sure that I'm not altering the original variable, I have to explicitly say copy. Otherwise, I'm just always working with the same thing, like in terms of data. And this applies to both lists and dictionaries, and also other stuff that we will be seeing along the way. So this is an important concept to keep in mind. Yes?
So even if I wrote another list is equal to a list plus something, then I'm also changing a list.
No, so good that we clarify this. This is exactly what I was saying is the difference between using append and extend or like this plus operation. Because if I do something like this, so here another list is actually the outcome of this operation, right? So if I look at another list, it has those 3 elements. So let's change the first element into true, and let's check what happened to the original one. It's not changed because when you do that plus operation, actually that plus operation is implicitly copying everything. So this is what I was saying when I was talking about the difference between calling .extend or calling .plus. So if you want to, like, if you are caring not to duplicate your data because it's large in memory or whatever, you should be using extend because extend is changing the variable itself without creating new things in the computer memory. Well, if you're actually not caring about this and you're happy with a new variable, a new list being created with a new chunk of memory to be dedicated to remember this variable, you can actually apply the plus operation, and this creates, like, this is, like Python is actually producing an entirely new event. There is a lot of kind of arbitrarity of the language. Like, those are all idiosyncrasies of this specific language that makes it different from other kind of languages. And so this is why, like, you have to, like, keep this concept in mind. There is no way, like, it feels intuitive to me just because I have been doing this many, many times. It's not intuitive at all, and it took me some time to struggle with this. So feel like, don't, like, it's normal to be confused. Probably if you're not confused, there's something that's you have not. No, I don't know. You can also probably not be confused, but this is not an easy concept to grasp, and you will probably struggle with this at the beginning. Okay, yeah, so this is just in words what we were just saying, and we can use the copy method. And again, all this applies to both lists and dictionaries. Okay, so there is a practical for dictionaries that should not be too long, so maybe you guys can get through it.
iniziassi Google.
Sorry?
C'era una posizione per ricordo che Python in Google.
No, in
Il
modo...
mio supervisor mi diceva che io ho imparato il master per così.
No, ma adesso
Non fa nulla.
Adesso c'è ChatGPT.
È vero, però per l'unico sicuramente quel linguaggio non sono confident. Perché sennò non imparo più.
Sì, però fa molto bene per farsi spiegare le cose.
Quello che c'è, lo uso per
Cioè, ormai
degli
piuttosto che
altri.
googlarla è più facile chiedere.
E quindi si può fare vi sei dimenticato la
You have to tell them that they go in. Yes,
Hai
yes.
aperto la grafica, stai chiudendo la no, non hai chiuso la se sei già
This is correct. Maybe another way of doing it is using, instead of writing explicitly the first word, the second word, you have a variable that's storing all those words.
And this will be the name, the key.
The key,
This will be
exactly.
the key, and this will be.
But-
Okay, so.
Okay, so for the sake of time, given that those practicals were like this was a very short exercise, I would actually check it out and continue to the other two variables types that I wanted to get to during this lecture. So, yes, this was very minimal exercise. You were just asked to go back to the list of words that we have. So this word list, which for some reason I cannot, okay, and the idea was to create a very simple dictionary like word lang dictionary with the like where we use as keywords some of like the first three words, one word, second word, third word, and as value the length of that word. And I mean, we will see how to do operations like this in a smart way, because like the code that I will be writing now is crappy. But for now we would do something like this. So in this way we are indexing the first element of word list, and we are directly inside the brackets where this will be used as the string. And we are assigning as value the length of the same string. Okay, so if people want to have very explicit, like many line codes version for this, we could also do something like this, which probably could make this easier to parse. Word list 0. So let's say first word. And so now we use first word as the key, and we just ask for the length of first word. And we can go second word, well, whatever, you got the sense. We could do this. Obviously, we will never be writing down multiple times operations for many elements. We will see how to iterate those in a smarter way. Yes?
So we try, for example, using the dict function. I know that you say let's skip this, but if you go with the dict function, it doesn't work.
And actually, yes, there might be some idiosyncrasy. Exactly, because, and this is why I was just talking about those brackets. Yes, because there are some like yes, because that's calling a function. We will get back to that when we will be looking at functions. Okay. Yes. So that was quick. Let's get through the last part where we look at other two slightly more like lists and dictionaries are by far the most common data containers that you will be using in pure Python. Then there are other stuff for matrices that we will be seeing in next lectures. There are other two types that from time to time actually make a lot of sense. So one of those types is tuples. And tuples have some similarities with lists. So they are again ordered. So we index them using numbers. They also can take whatever content, like we can mix variable types inside a tuple. But the important thing about tuples is that contrarily to lists, they actually cannot be changed in content. They are said to be immutable. Okay? So once we define the variable tuple, that tuple is set forever. So this is a tuple. We can index, we can look up what's inside that variable. But if we try to alter the content of this tuple, we actually get a type error. Type error means we are using this type in a way that is not supposed to be used. So we were trying to override the first element of the tuple, and Python is telling us, screw you, I cannot do this. And this is very, like, sometimes it is actually very useful to make sure that the content of what you're using cannot be changed. Like, there are some, in general, if you are not explicitly expecting your values to change, you can think of working with tuples. Yes. So in general, if you are thinking about like collecting together some elements that you want to index in order, but you are not planning to change them, like extending the length or change elements inside, consider using tuples. They're also slightly more efficient. That's the idea. Like to keep things flexible, you kind of lose on the efficiency side. Yes.
What if I make a list that is equal to a tuple?
You can convert a list to the tuple. Like you can take the tuple, you can convert it to a list. I can actually do this. So are people free? Well, let's make this full screen. So we can define a tuple. Oh, sorry, most important thing. Tuples are defined as lists, but instead of square brackets, we are putting round brackets. Okay, just for defining them. When we will be indexing them, we stick to the square brackets that we like Python. All sort of indexing operations are always square brackets. For defining tuples, we use round brackets. So we can say 1, 2, 3. So now let's write a variable list from a tuple equal to a tuple. Well, actually, the way we convert this to a list is, we have not introduced it yet, but is fairly intuitive. There is a function that is called list that just convert whatever we pass, if it can be converted. Like, not every time it can be converted. But for example, a tuple is something that makes a lot of sense to convert to a list. So if we pass a tuple to the function list, this will just take the tuple content and will put this content in a list. Okay, so sorry. So now this is a list of 3 elements where we can, and now that this is a list, we can actually change its content. We can say element 0 equal to blah. Okay, and now we can go and check this value. And now we have changed the first element. What happened to the tuple? Why?
Because it's unchangeable.
Yes, not only that, but because whenever, like when we have called that list operation, we have just copied all the content of the tuple and put it in a new memory location in memory. Okay, so we are not referring to the same space in the memory computer anymore. When we are doing this list operation, we are implicitly also calling basically copy.
Okay, because without the list operation, I would have just created another tuple.
Exactly.
And can we also convert the list to tuples?
Yes, exactly. Same way we can also say up, well, fairly intuitive. Okay, no, wrong slide. We were here. So last variable type that I wanted to have a look at are sets, and this is also like not so common to see, but actually many people are not using them because they're not aware of them. Sometimes they can be super useful. So a set is a collection of elements where elements are not ordered. So sets are actively useful when we are not caring about the order in which we put elements. Okay. So for example, if we want to if we want to compare ensembles of stuff, we want to create a list, we want to create another list, and we want to we will get to these comparisons. If we want to compare two lists and the lists have the same numbers just in different orders, those two lists are different because order matters for lists. They are ordered sequences. Okay? So sets are unordered collections of stuff. So we are putting stuff there. We cannot use numeric indexing anymore because they are not ordered. It's not that every element has a position in the set. But it can be useful because, well, we will get to this super soon. And actually, so yes, let's introduce the problem. If I'm trying to compare those two lists are not the same. So, but you can imagine sometimes for whatever operation that you're doing, it's useful to collect stuff in a way where the order in which we collected it does not really matter. And so the way to make this comparison the way we want it to be is to define sets. And sets we use the curly brackets, and all of this is entirely idiosyncratic, and like there is no reasonable way why to use one or the other. You will have to remember, but hopefully it won't be. There's also probably a more intuitive way, like you can also just say set and convert a list to a tuple. A list to a set. But to define it from the very beginning, we can just use the curly brackets. But now we are not writing key value, key value, key value as we were doing for dictionaries. We are just writing values separated by commas, and that's how Python infers that this is a set and not a dictionary. Okay. So this is create this set. We can use the type function to ask Python what type this is, and it will say this is a set. And if we actually now write that like this equal to this, now this would be true, because for sets we are just putting stuff together based on what they have inside and not the order that they have. Okay, so sometimes they can actually be very useful. For example, if you have a list like 1, 2, 3, well, let's say 1, 2, 3, 3, and we come. Okay, so let's start from this. So we have a list. We can write set a list, and this just convert this to a set. So just imagine that we have some of the contents of the list that is duplicated. Okay. In this case, Python knows that these and these are different just because they occupy a different position in the list. So the moment we convert that stuff to something where order does not matter anymore, what do we expect to happen?
You will only have one.
Exactly, we will have just one element. And this is actually, I think, probably the most efficient way in native Python to just remove duplicates out of lists. Okay, so this is probably where I use this type the most. But also for the comparisons, this can be fairly useful. And yeah, we can introduce new elements or remove them. But remember that since like now indexing does not make sense, like in sets we do not have indexing, right? Like since those are not ordered in some way, we cannot put numbers to refer to things. Okay, so if we cannot write anymore, like as we were using for like we cannot pop stuff, we cannot append stuff because we are not putting stuff at the end. So the methods to work with sets have different names, and they are actually remove and add. I hope that everyone can see. So here I am. Well, sorry, this is cropped at the bottom of the slide. Let's make this a slide. So we can define a set. We can remove an element. So this will be just the previous set without an element. And we can add an element. So now this will also have a new letter. Okay. So those are, again, in-place methods, just that change the content of the variable. But we can also, exactly as we were doing for lists, write operations like no, actually not, sorry. Forget about what I was saying. There are probably reasons for this, which will be, yes, clearer here. Also for doing those operations, we actually, if we want to add and subtract, we actually have to explicitly use a method. So let's say we have set A and set B. If I want to, if you remember some set theory from high school, there is this union operation that you can do on sets. So if you want to say everything that is in this set plus everything that is in this set, you can write, and this put everything together. If you have some elements that are duplicated across sets, like in this case letter D, you can see we just get one of the two. Okay. And we can, in the same way, we can take the difference between sets. So, which means everything that is we are removing from, we are taking from element A, everything that is not contained in set B. Okay. And there is also an intersection, yes, intersection, which is set intersection operation, which is everything that is in set A and everything that is in set B. So set lectures from high school, like intersection, union, difference. Those are sometimes useful operation to do on stuff that you have put in a variable. So yes, final word on those data collectors. Try to remember that you have all those options where whenever you're working with putting multiple variables in the same thing, because all of those have you seen different uses, different applications, and sometimes you can use multiple types for the same thing, but most of the times, if you remember the Zen of Python, in the face of ambiguity, refuse the temptation to guess. Sometimes there are reasonable way to choose one option or the other. So you have to think, what am I doing with this? Do I have to change the length of this data collector? Will I add new stuff? Do I care about the order? Does it make sense to give stuff names, like string names that I can use later in my code for making it more readable? Should I just use numbers? Those are multiple, most of the times there will be a reason to choose one or the other. And I hope it will be evident in maybe not immediately now, but when we will get to more interesting things in future lectures. There is another practical that we can start now, and we will be correcting at the beginning of next lecture.